using a one-period binomial model. We're going to cover this learning module in 3 videos. The first one is going to cover the introduction, the binomial valuation, and the binomial model. The second one will cover the pricing of a European call option, and the third one is going to cover risk neutrality. So in the first video, we'll get into the introduction. In the second one, we will get into how to value a derivative using a one-period binomial model. And in the third one, we'll get into risk neutrality. So let's get started with an initial discussion about binomial valuation. Now, why is there a need for this binomial valuation is because when we talk about options as compared to forward commitments, there is a difference. For forward commitments, you have a symmetric payoff that if the spot price will go up, you're going to have a higher profit, right? And if the spot price will come down, you're going to maybe even have a loss. So this is what is a symmetric payoff. But with an option, what we have is that, let's say it's a call option. If we're talking about a call option, it will go up in value if the spot price goes up, right? You will have a profit. But if the spot price comes down, you're not going to have a loss because the option will not be exercised. So you'll have a asymmetric payoff. And because of this difference in symmetric payoff and asymmetric payoff, since the options have asymmetric payoffs, we need some kind of model to factor in the random price behavior of the underlying asset, because the option will only be exercised if the spot price is going up, and then we will have this profit, right? But if it is going to go down, then we're not going to exercise the option and there will be no profit, but there will also be no loss. So it depends on the behavior of the price of the underlying asset, and the behavior is random. So we need to somehow have a model that we can use to model this random behavior. And one of the commonly used models is the binomial model. Now, practically speaking, what is used in the market now is the Black, Scholes and Merton model, which you will learn about at level 2 in detail. But for now, at level 1, you're going to have to learn about the binomial model first, which was used before the BSM model. But now the BSM model is used more for option pricing. And the binomial model is not used that much anymore is because it's so simple. It's very, very simple. And it assumes that either the stock price can go up. So let's say we have a current stock price of $80. So this model assumes that either this can go up, so the up stock price can be 120 or let's say 110, and the down stock price can be 60. So not only does it assume that the price will either go up to S up or go down to S down, but it even assumes the exact amount it will go up to if it goes up, and it even assumes the exact amount it comes down to if it comes down. So this is a very, very simple model which tells you that, oh, the stock price can either go up or it can come down, and if it goes up, it will go up to this, and if it comes down, it will come down to this. So practically speaking, obviously that is not something that you can try and predict, right? I mean, who knows where the stock price will go if it goes up, or where it will go down if it goes down, and whether even it will go up or down, or maybe it will just stay the same. So this model assumes that no, it will not stay the same. It will either go up, and if it goes up, it will go to 110. If it goes down, it will go down to 60. To use this model, we actually need to assume that what will be the price of the stock if it goes up, and what will be the price of the stock if it comes down. This is the first assumption. Second thing is the probability of going up versus the probability of going down. So let's say this is the probability of going up, and 1 minus that is the probability of going down, and naturally they will always both add up to 1 because together it is 100% probability. Either it will go up or it will go down. Next, As far as the valuing of the options is concerned, we don't need to know the probability of going up or down. All we need to know is if it goes up, what will be the price, and if it goes down, what will be the price, and what is the current price, right? So if, for example, the current price is 80, and if it goes up, it will go to 110. So 110 divided by 80 is 1.375, which means there will be a positive return of approximately 37%. So when you divide S up by S naught, you get 1.375, and since this is greater than 1, that means what you have is an up move with a positive return. You're getting more than what you started with. You have 1, which is what you started with, and then you have 37.5% more. Whereas if we look at the down situation, and let's say it's going down to 60, so it will be 60 over 80, which is your S down divided by S naught, and 60 over 80 is around 0.75, which is obviously less than 1, which means your down return is 0.75, or you've lost 25%, and your up return is 1.375, which means you have gained 37.5%. And you can see this in the exhibit 1 in the curriculum, that if you are starting off with a price of 80 and you're going to a price of 110, so S up is 110, which can also be written like the return of up, which is 1.375 multiplied by S0, which is 80. Right? And that is what this formula is showing. And if you're going down to 60, then that S down is 60, which can also be written like the return, which is 0.75 multiplied by S0, which is 80. So this is the basics of the binomial model. Now in the next video, we will use this binomial model to calculate the price of an option.